Assalamualaikum to Encik Wan Afnizan bin Wan Muhammad. We are from Group 4. We'll present our group project on the topic of mitigation methods for flash flood case study of Taman University Parit Raja, Batu Pahat, Johor. Okay, my name is Harid Daniel. I will start our presentation with introduction. Okay, a flood is defined as any high water flow that dominates the natural or artificial banks in any part of the river system. Therefore, when a river bank is overstocked, the water extends over the floodplain and generally becomes hazard to the society. Along with the increase in water quantity, urbanization result in the increase in non-point pollutant from various municipal land use and activities which can all end up in receiving waters. This overflow of water can result in significant damage to infrastructure, erosion and riverbanks, and even endanger human lives. I will continue the presentation about the study area. Okay, in the project instruction, it stated the study area of this project was located at Taman University Parit Raja, Batu Pahat, Johor. Okay, we have two drainage. Okay, drainage 1 and drainage 2. For the drainage 1, the existing drainage existed by the main road have a length approximately 493 meter from Ricia Mokofi to Sohaila and H Bistro. It has a depth of 2 meters, 5 meters wide, and the average slope along the drain is 0.5 meters. Okay, for the drainage 2, the length is approximately 335 meters from Sohaila NH Bistro to RG Grand Hotel. Uh, it has the depth is 0.6 meter, the width is also 0.6 meter, and the average slope along the drain is 0.4 meters. For the problem statement, the existing drainage system was not sufficiently planned to prevent floods and heavy rains from overflowing onto the road. Okay, for the second problem statement is designing the stormwater drainage system requires careful analysis of the flow channels size since it is inappropriate for the region. So these are the objective of our project. The first one is to propose the idea of a proper drainage system to put out an effort to successfully lessen the heavy flow. The second one is to determine the ideal size and type of drainage system for Taman University Parit Raja. Okay, the last one, to analyze the water's flow via the proposed drainage system at Taman University Parit Raja, Batu Pahat, Johor.
Hi, Assalamualaikum. My name is Nur Hafizah binti Muhammad CF220185. So, I will present about methodology. So, this is the steps for estimating a peak flow from a single subcatchment for a particular ARI using the rational method. There are all 7 steps. The first step is select design ARI. We can get information from the table 2.6.1, which is quantity design storm ARI. Second step is discretize subcatchment and divide subcatchment into segment of homogeneous land use or surface slope. The third step is estimate time of concentration, estimate overland flow time, and refer table 2.5, which is equation to the time of concentration. We need to estimate flow times for all other flow components within the subcatchment, such as curb and gutters, pipe and channel. The next steps is determine average rainfall intensity. We need to calculate I for design ARI and duration and equal to the time of concentration from IDF data for area of interest. Refer table 2.6 and formula below the table 2.6.1. Steps number 4 is estimate runoff coefficient, and we need to refer table 2.6.2 and estimate C values for each segment if there are different land use. The next step is calculate average runoff coefficient. The formula has stated at explanation 2.7 in our report. Lastly is calculate peak flow rate Q for the subcatchment. The formula we get from 2.8 has stated in the report.
My name is Nur Afrina binti Muhammad Zainuddin. I want to present about the analysis and result. To gather some critical information, a survey was carried out throughout the study region. To determine the width and the depth of the trench, we use equipment such as a measuring tape to measure. Additionally, a study of the area, flash flood, and the direction of the drainage water was conducted. There are three causes of flooding in the Taman University Parit Raja. The first is the soil infiltration rate. This is so that it is clear from the past study that the soil type at Parit Raja is silty clay with a little ability for infiltration. Therefore, a suitable drainage system needs to be built in order to prevent the above scenario from the occurring and to lessen the damage if it is unavoidable. The second is irregular concentration of the earth drain flow channel. The drainage channel is the conduit for water being carried by the earth drain. Unlined channel also does not have a consistent slope and cross section, which reduces discharge of flow draining out to outlet at downstream. The third causes of the flooding in the Taman University area is also caused by the dumping of the garbage into the drain. The unsystematic garbage disposal will cause the drain to be blocked. This causes when it starts to rain, the condition of the drain filled with garbage will cause flash floods. When the drain is filled with garbage and the plain, it will cause the waterway move slowly. Therefore, the irregular disposal of the garbage affect the flow of drain. Next is the drainage calculation for the O drainage. There are two types of drainage that have different shape. This is the calculation for drainage 1. The size of this drainage is 5 meters for T, Y is 2 meters, and B is 3.8 meters. For this calculation, the value obtained to get the Z value is 0.577. Using the table 2.3 to calculate for area, perimeter, and hydraulic radius is 10 meter square, 8.46 meter, and 1.1 meter. Then the slope value is 0.0041. Refer to table 2.2 to get the TD value, which is 3.99 minutes. For the type of development is commercial and business center, and minimum ARI is 100. The value for the calculation of a land flow TO is obtained by referring to the table 2.5.1 to obtain the heterogeneous value, and the value will be included in the overland flow formula. Then the TD and TO value obtained will be added to obtain the time of concentration value TC. The TC value obtained is 39.278. The next calculation is the empirical IDF curve. For calculation, it is necessary to refer to table 2.6 to obtain the value of lambda, K, theta, and n. The value obtained is 4 to 4.50 mm per hour. Then the determined runoff coefficient value is 0.95 based on the reference table. After that, the obtained coefficient value will be entered into the C average calculation formula. The last step is to calculate the peak flow Q. The result of the peak flow calculation is 1.20 meter cube per second.
Okay, my name is Mark Fidos. So I continue to calculate the new design for our project. So first of all, I will show you our new design for our projects, which is the trapezoidal channel section of drainage. So I will show the calculation of the first channel. So we firstly we find out the slope, which is Z. So Z is 0.7, and then we continue to calculate the area, parameter, and the radius. And then we go through for the S, which is the sectional friction slope. So we got 0.04, sorry, 0.0041. So after we got the S, and then we will continue to calculate the D. So D is equal to TD, which is the travel time in drain. So after we got the TD, and then we got the T, which is 0.0 uh, 54 hours. So after that, this is the type of development business and develop. Uh, so the ARI is equal to 100. And then we continue to calculate the TO. TO is overland sheet flow travel time in minutes. So after we get the TO, so we will find out this TC, which is the TD plus TO. And then we got the TC is 38.49. So and then we continue to find the I. I is the average rainfall intensity in millimeter per hour. So we find out the R, which is the formula is lambda T power of K divided D plus theta, the power of roughness. So the roughness we'll find out in table. So after we got the answer, I is equal to 442.23 millimeter per hour. So and then we find out the runoff coefficient, which is C. So the land used for this project is commercial and business center. So the runoff coefficient, which is 0.95, is above the 10-year ARI. So we consider in the table of runoff coefficient. And then the last one, we'll find out the Q, which is the peak flow in meter cube per second. So the formula is CIA equal to CIA divided by 360. So you get the Q or peak flow is 11.67 meter cube per second. So this is our analysis. So the first one is flow rate of the passing through water for the drainage system is still lower. So we designed the new drainage and come up with the idea to realize the drain include the slope and depth. So we designed the new drainage with the difference length, depth, and slope. So when heavy rain or water flow rate increase, so the drain can support the and prevent the water from overflow. Also to get better water flow passing through the drainage. And then the drainage channel 2, we also redesigned the new drainage to get the highest water flow rate compared with the old design. Uh, so it can accommodate a lot of water capacity. That's all.
Hi, my name is Lauren Zaka, Singh. I will present about discussion of our project. So after we did the calculations, for British one, we obtained the flow rates increasing by 4.2% from 11.20 meter cube per second on all design to 11.767 meter cube per second on new design. So for Greenwich 2, we obtain the flow rates increasing by 104.7% from 0.402 meter cube per second on old design to 0.8323 meter cube per second on a new design. So the flow design of the discharge exceed the peak, indicating acceptable new channel section design, and the flow rates of drainage size varies with channel length and depth. In negative drainage, length and depth will prevent a flash loop from during rainy day. Okay, so conclusions. Hydraulic is crucial in civil engineering for drinking water resource. Infrastructure to minimize environmental damage to prevent flooding, effective on-site drainage is essential. Cities face flooding issues, particularly during monsoon season. Hydrology and hydraulic studies are needed to determine peak discharge and design optimal drainage. Data on many rock wave coefficient, friction slope, IDF, and uses by and ARI are used to analyze drainage and recommend the best design. Flood management is essential to provide rapid assistance and implement substantial mitigation measures to catch up with urban expansion.